Hello viewers, welcome to the session on data structure. In this video, we will see about binary tree traversal, where types of traversals like in-order, pre-order and post-order traversals are discussed in detail. Hope you have watched my video on binary trees. Recollect the definition of binary tree. It is a finite set of nodes that is either empty or consists of root and two disjoint binary trees called the left subtree and right subtree. Here, no node can have more than two children. Let us see what is meant by traversal. Traversal is the process of visiting all nodes of a tree exactly once based on certain order. There are three types of binary tree traversal based on the order in which the nodes are visited. They are in-order traversal, pre-order traversal, and post-order traversal. When we traverse a binary tree, we want to treat each node and its subtrees in the same fashion. Assume L stands for moving to the left subtree of the node. D stands for visiting the data of the node. R stands for moving to the right subtree of the node. Then there are 6 possible combinations of traversals: LDR, DLR, LRT, RDL, DRL and RLD. When we follow the convention to traverse left before right, only 3 traversals remain. They are LDR, DLR and LRD. The types of traversals are defined based on the position of D. In the in-order traversal, LDR is followed, that is, first traverse left subtree of the node, then visit the data of the node, then traverse to the right subtree of the node. Whereas in the pre-order traversal, DLR is followed, that is, first visit the data of the node, then traverse the left subtree of the node, then traverse the right subtree of the node. Whereas in post-order traversal, LRD is followed, that is, first traverse the left subtree of the node, then traverse the right subtree of the node, then visit the data of the node. Let us see each type of traversal in detail with an example. The in-order traversal follows left, data, right order. The recursive routine is written to perform the in-order traversal, which is shown here. Start from the root of the tree. Traversal can be performed only when the root is not null. Hence, when root is not null, perform in-order traversal in left subtree, then visit the node, then perform in-order traversal in the right subtree. The process is repeated in each node in same fashion. When we reach the leaf node, move back and continue with the remaining process. Let us visualize the in-order traversal process with an example. Consider the tree shown. Let us perform the in-order traversal in this tree and find the output. Begin from the root. Start applying LDR at the root node A. Hence, traverse to the left subtree of A, that is node B. Then apply LDR at node B. Hence, traverse to the left subtree of node B, that is node D. Then apply LDR at node D. But as there is no left subtree of D, proceed with visiting the data of the node. Hence, we get D as the first node visited in the output. Proceed to the traversal to the right subtree of D. As there is no right subtree of D, consider the LDR process is completed at D and move back. At node B, already L is completed, so now visit the data of the node. Hence, we get B as the next node visited in the output. Then proceed to traverse to the right subtree of B. Now apply LDR at node E. Hence traverse to the left subtree of E, that is node H. Again apply LDR at node H. But as there is no left subtree of H, proceed with visiting the data of the node. Hence, we get H as the next node visited in the output. Then proceed to traverse to the right subtree of H. There is no right subtree of H, so consider LDR process is completed at H. And move back. At node E, already L is completed, so visit the data of the node. Hence we get E as the next node visited. Now proceed to traverse to the right subtree of E. As there is no right subtree, consider LDR process is completed at this node and move back to node B, then move back to node A. At node A, already L is completed, so visit the data of the node. Hence we get A as the next node visited in the output. Now proceed to traverse to the right subtree of A. Again apply LDR at node C. Hence traverse to the left subtree of C, that is node F. Again apply LDR at node F. But as there is no left subtree of F, proceed with visiting the data of the node. Hence we get F as the next node visited in the output. Then proceed to traverse to the right subtree of F. As there is no right subtree of F, consider LDR process is completed at F and move back. At node C, already L is completed, so visit the data of the node. Hence we get C as the next node visited in the output. Now proceed to traverse to the right subtree of C, that is node G. Again apply LDR at node G. But as there is no left subtree of G, proceed with visiting the data of the node. Hence we get G as the next node visited in the output. Then proceed to traverse to the right subtree of G. As there is no right subtree of G, consider the LDR process is completed at G and move back. As LDR is completed at node C, move back to node A. At A also LDR process is completed, hence in-order traversal of the tree is completed. If we observe the output, the node visited by applying in-order traversal are in order D, B, H, E, A, F, C, G. Next let us see the pre-order traversal. It follows the data left, right order. The recursive routine to perform the pre-order traversal is shown here. According to the algorithm, visit the node first, then perform pre-order traversal in the left subtree, then perform pre-order traversal in the right subtree. The process is repeated in each node in same fashion. Let us visualize the process of pre-order traversal with this example. Start from the root node. Apply DLR at each node. By applying D at node A, we get A as the first node visited. Then apply L at A. So we move to the node B. Applying D at B, we get B as the next node visited. Then apply L at B. So we move to node D. Applying D at node D, we get D as the next node visited. Then apply L and R at node D. As there is no left and right subtree of D, DLR process is completed at node D. Hence, move back to node B and proceed with R at B. Now, move to the right subtree of B, that is node E. Applying D at node E, we get E as the next output. Then apply L at node E. Hence, we move to the node H. Applying D at node H, we get H as the next output. Then apply L and R at node H. As there is no left and the right subtree of H, DLR process is completed at node H. Hence, move back to node E. Apply R at node E. As there is no right subtree, DLR process is completed at node E and move back to node B. Here also DLR is completed, so move back to node A and proceed similarly at node A. By repeating the process in the right subtree of node A, we get the output by traversing to C, F and G. We observe the output, the node visited by applying the pre-order traversal are in the order A, B, D, E, H, C, F, G. Next, let us see the post-order traversal. It follows left-right data order. The recursive routine to perform the post-order traversal is given here. According to the algorithm, perform post-order traversal in the left subtree, then perform post-order traversal in the right subtree, then visit the node. The process is repeated in each node in same fashion. Let us visualize the process of post-order traversal with this example. Start from the root. Apply LRD at each node. Apply first L at node A, we move to node B. Applying L at node B, we move to node D. Again applying L at node D. As there is no further left subtree, then apply R at node D. As there is no right subtree, then visit the node D, by which we get D as the first output. As LRD is completed at node D, move back to node B. Now apply R at B. So move to right subtree of node B, that is node E. Now apply L at node E. Hence move to the node H. By applying LRD at H, we get the output H. When LRD is completed at H, move back to node E and proceed to apply R at E. As there is no right subtree of E, proceed to visit the node E, so we get the output E. Now as LRD is completed at E, move back to node B. Visit the node B, by which we get the output D, B. As LRD is completed at node B, move back to node A and proceed similarly at node A. By repeating the process in the right subtree of node A, we get the node visited as F, G and C, then A. If we observe the output, the node visited by applying the post-order traversal are in order D, H, E, B, F, G, C, A. Hope now you have clear with all types of traversal. Let us try to solve the practice problem. Find the in-order, pre-order and post-order traversal of the given tree. The solution by applying the in-order, pre-order, post-order traversal is given here. Hope you made it right. There is a natural correspondence between the traversal and producing the infix, postfix and prefix form of an expression. Let us see the expression tree in my next video. Have a happy learning.